So, welcome everybody. Before we begin, if you need a translation device, now is the time to get one. So, take your time, just so we're all on the same page and let the flow of people go. How is it going so far? Good? For the questions, I speak Slovak, so we can answer them in Slovak. So feel free to use Slido and ask them in Slovak as well. And yeah, I will begin. Could I get 3 chicken hearts, please? I asked the butcher. He looked at me with confused facial expression. What do you need 3 chicken hearts for? We sell them in kilos, not pieces. This was the answer of most people when it came to my passion for surgical sewing. It felt like my only soulmate is my roommate, and we used to do surgical suture in our room. I always needed 3 hearts. One was for beer lumber suture. The second one for square knot with one-hand technique. And the third one, just in case I place the suture too close to the wound and it breaks. We started like this in our dorm at Leaf Academy. We used to put the heart on the table and perform heart bypass surgery. And at that time, I really thought that the remainder of the story will be using robots for surgery. And I followed this passion, and together with my roommate, we founded an NGO, Medcon, as you could hear, and we created a community of young people that want to build the future of healthcare. And we created a medical case study competition where students are given anamnesis, scans, blood tests, and then with all this data, they are trying to propose differential diagnosis, choose a diagnosis, and propose reasonable treatment. And this competition has reached over 1,000 students as of now. We have translated it to 4 languages, and we also raised about 50,000 euros to help people from all socioeconomic backgrounds to prepare for medicine. And one of the primary motivators for this was that there is severe underrepresentation in healthcare. There were studies showing that if there's a female or someone of a particular ethnicity, and if they're treated match-paired with the same sort of prototype, they have better outcomes. And therefore, we need to work towards diverse healthcare where we have clinicians from all sorts of backgrounds, and this is something we're aiming for. But then also we wanted to create a community, so besides creating these medical case studies, we organized summer school where best students came and they got the opportunity to use stethoscopes, to draw blood, to perform direct laryngoscopy. And as a former debater, I also brought a little element of this into the summer school, and we organized a debate. And our motion went like this. Do we value more art or science and medicine? Because it's a combination of both. And I'll just do a little poll. Please raise your hand if you believe medicine should be a science, as opposed to art. Okay, majority of you. What about art? Now, raise your hand if you believe it should be an art. Interesting. All right, so apparently I don't have as many people to persuade, but my side believes that it should really be science. And this, ladies and gentlemen, is an example of bloodletting. So if you have been in Egypt 3,000 years ago, and you would like to improve your circulation and detoxify your organism, they would propose to take up to 2 liters of your blood. And then, you would do quite great. You would really not feel any pain anymore, just because you would be lying on your bed for about 2 days until 40% of your blood volume recovers. And this was later proven by science that it's detrimental to your health. And it was really the introduction of scientific method. And this really inspired me as someone who wanted to go to medicine and follow all the protocols and really, bring all the innovation I saw. I felt like just studying medicine will not be enough. And this is, ladies and gentlemen, when I decided to switch, and I majored in bioengineering and computer science with specialization on computer vision and radiology. And right now, I will show you examples of how AI will shape the future of healthcare. And I'm pretty confident that AI is a great tool to not only fasten the healthcare, but increase the accuracy. But there are some pretty common mistakes, and we're gonna fix them right now. So this is from a study. If you went to Boris' lecture, it's kind of similar what he was talking about. So we get thousands of features, including your age, your gender, your diagnostics from the past. And then we took all this data and used machine learning to detect frailty. And what we found out is that one component we're missing is pre-frail. So doctors are doing really good at diagnosing if someone is frail or not frail, but they're not so good in diagnosing this mid-ground. And this is really important because without prevention, many of these frailty cases are not handled soon enough. And therefore, we decided to create a suite of different sensors, force sensors, and different tests that are able to predict frailty better. And what I'm showing you right now is a very common schema of how machine learning goes. So if you ever wondered what is behind ChatGPT or other LLMs that you might be using, large language models, this is the workflow, but this is workflow for traditional and deep learning. And this was really the beginning of AI. And it was as soon as 1950 when this was introduced. And the two components I want to bring our attention to is one, training set. So when you're using ChatGPT, you're feeding it some sort of information, and this is called prompt engineering. So you give it a lot of data, something related to what you want to generate. Ideally, don't disclose hundreds of pages of secure, private company data when drafting an email. So you want to be a little bit picky about what you feed into the model. But it's really important that you choose this information right. And this is the major component. This is what we spend majority on time on when processing healthcare data in AI research. We do pre-processing. So when you get any sort of data you want to use, the main component, and you can see it's the widest box, that's why it's showing that's important. We do all these imputations, scaling, and normalizations just to make sure that our data is as clean as possible. Because as soon as there is a noise, the AI model will capture it. And that's what it will give you later. So your result is as dependent on the quality of the data you feed in as on your model itself. So later you select the model, and that's a long story. But one thing that is really important is the model evaluations, and we use different sort of metrics to do this. And one of the metrics is F1 score, and there we are looking at accuracy and precision. And when we were training and benchmarking these different models, what we found out is that most of the LLMs, especially in image generation, are extremely biased. So one of the specializations I was doing is software engineering, and my professor was doing research on the bias in LLMs. And they generated thousands of pictures of software engineers, and 20% of software engineers in Europe and US are females. And then the images they got from the LLM was about 2%. And this shows the extreme degree to which these LLMs over-exaggerate all biases. And therefore, we need to be aware of them. Second, I worked on a research study for detection of Alzheimer using EEG, electroencephalography. And we were using this data because it's time series. And as of now, we have good methods to deal with this sort of data. So it was 1950 where traditional LLMs or traditional models were introduced. And it was as late as 2017 when transformers were introduced. And it's not that sort of transformer series. It's an architecture, it's a deep learning architecture that is able to process time series data. And if you give it 2 words, then it can predict the next one. it's used in language processing, and it's most likely what you're using right now if you have the translation device. Now, when we are detecting Alzheimer, we needed to break it down into multiple components. So we broke it down to spectral, graph, spatial, and we were extracting different features from there. But that's not really what I want to talk about. I want to talk about the cross-attention. And attention is a powerful tool. Attention shapes your experience. Just because some of you might be more entertained by a robot I show you at the very end, he's called Albert, he's very cute. And some of you might be more entertained by seeing a movie or having a popcorn upstairs. And some of you might remember pedaling the bike. It's really your attention that brings your experience. And this is what they used in transformer architecture. They're putting the attention on the words and phrases in language processing, for example, that really determine the next word. And this is important when prompt engineering your LLM, because you want to tell the LLM what kind of output you want. You kind of want to give it a filter. You want to say, oh, this is your appeal. This is how you want to sound like. And this is what you should pay attention to in all the documents I have given you. So from now, we're able to use this EEG data, and we did it in AD Alzheimer diagnostics. And what you're seeing right now is a connectomo. So it's showing brain, and the nodes are showing different brain regions. And what happens in early Alzheimer is that the front part of the brain overtakes the back part just because it's a little bit weaker. And these sort of pictures are telling us how to better navigate the early diagnosis. And if you follow all the advice Boris gave you, you'll definitely be at lower risk of detecting Alzheimer. So now, after we have done deep learning, machine learning, foundational models is the next. So foundational models, these are quite a few examples, and I want to check with you. How many of you have used at least 3 of the ones I'm displaying on the screen? Can you raise your hand? Okay, that's a good audience. So I would expect that the ones you haven't seen is Granola. So it's for transcribing your meetings, and it identifies each speaker, and then you can track down to that speaker, and it creates concise notes. Then maybe DeepL for translating your documents. And then there is Copilot version for GitHub, which is writing code. So as of now, there is no longer an excuse of not being able to write code. You can all do that. It's very simple. So now I will talk about the future of AI. This is what it was until now, and the models are extremely powerful. If we deploy these models in healthcare and we transcribe meetings with patients and we use all the diagnostics I have shown you and we just start using what we already have, the healthcare would look completely differently. Now, what will be the future of AI is, one, fine-tuning these foundational models, which are already extremely powerful, and second of all, doing reinforcement learning. So using Piaget method of just reward or punishment to train these models and bring some human features into them. Are you ready? All right. So as I mentioned before, this is a cycle, and it really starts with early diagnosis. So if there's early diagnosis, there is timely intervention, and it slows down the disease progression. And this is what I'm working on right now. So I'm really trying to make sure that any patients that have Duchenne muscular dystrophy or any sort of dystrophy are diagnosed early enough so we can intervene quickly. And this is the traditional process. So if there is someone who has passed genetic test and it looks like they might suffer from muscular dystrophy, they go for a blood test. They do 6-minute walking test, which is literally just walking for 6 minutes. And sometimes the degeneration is already in stage when they cannot really do that. And then they go for genetic testing. And that's really the cornerstone of today's diagnostic. So in these genetic tests, it determines a particular locus, which is a location in your genome. And if there's a mutation, there's likely muscular dystrophy. And then there is biopsy and sometimes MRI. Now, what we are doing right now is introducing a new biomarker. And this is sort of picture you have seen before. So it's, again, the segment of the muscle. And we can see the muscle from the top. And what we are doing is that we are using a segmentation model. There are many different types. There's SAM, MedSAM, and others. And we are using all the general information it knows. So it has really good generalizability. But what we are trying to do right now is to specialize it. So we feed it with muscle scans of Duchenne muscular dystrophy, and we tell it, this is muscular dystrophy, this is not, and then we do it on a scale. So eventually, we get the confidence interval of the diagnosis itself. And this is really the future of AI, because if we're able to fine-tune these powerful foundational models on different diseases, then basically, we need doctors only to double-check if these foundational models are right. There is a caveat to this, and it's a disclaimer that's important to make. Right now, Siemens was testing some models they have built, and what they found out that if radiologist is presenting with the AI result, and they're also showing possible mistakes that the AI model might have made, they look at it again, they take their time, but usually they question their own judgment. And actually, 70% of radiologists failed on this test. They either thought that the AI was right, or they thought that the mistakes that AI identified themselves of why it might be wrong was right as well. But it was not their judgment that they would use to say that the AI model is incorrect. And this is very serious, and it's really important that there's enough training going on. And I really believe it will be a cornerstone of education in the next decade to include how we should use these LLMs so we are still confident in our knowledge and we're able to learn. And we don't solely rely on the LLMs. And with this, we're able to realize that LLMs are mostly for increasing the efficiency, not for learning itself. So check the MIT study on how the brain changes when you use ChatGPT. Okay, so this is our patient. This is a standing test, so it's not the walking test. And just to give you a little bit of background, muscular dystrophies are shown by replacement of muscle into fat. And it's genetically predisposed, so it's severe life-threatening condition, and most of these patients have life expectancy of less than an undergrad. But currently, because of these LLMs, we're able to speed up the treatment development, and also we're able to monitor them better to better assess what kind of treatment works and what kind of does not. And why is this important is that we are right now in many bioethical discussions kind of discussing, oh, should we use these LLMs? We can do like 20% better of what we have currently. And this might be relevant to countries like Europe, where the healthcare system is already quite good. But thinking about Africa, think about diseases that have not been treated at all. There we should go a lot faster, right? Because it's comparing nothing to at least interacting with some sort of doctor. Many people in Africa have never interacted with a doctor. So that's why we should really think twice when saying, oh, I don't want AI model to determine my health. Yes, it depends on the context. So that's an important consideration you should keep in mind and maybe think about when you go into these discussions in future, because it will be really you, the public, shaping how far we can bring the AI in healthcare, because it's a decision of all of us. So after we have saw the patient, we have seen the patient, we look at what kind of scans we can do, and I said that MRI is a great biomarker. It's able to monitor, not only diagnose, this condition. So we need to be HIPAA compliant. That's in US, in European Union, there are similar standards. So all these data needs to be protected, and it needs to be anonymized and put into DICOM format, so it needs to follow very specific regulations. And this is, again, what I wanted to give you as an advice. Please be careful about what you feed into these LLMs, because as soon as you feed it to LLMs, it's the same as if you would be posting it on social media. It's no longer in your control unless you're using enterprise version of ChatGPT or some sort of paid version that has extra security level to it. Now, this is a mock-up. So again, we have the muscle, that's the MRI, and it can be with different sort of settings. So it can be T1 weighted, T2 weighted, Dixon, and what we are building is a device-agnostic model. So it doesn't matter if you use this sort of AI or if you use Tesla magnetic resonance with 1.5 Tesla or 3 Tesla. It doesn't matter if you use T1 weighted or T2 weighted. It can generalize across all of them. And this is great about AI models. They're like an agent that knows a little bit about everything and a lot about something. And of course, they would not perform that well on tasks that are outside of their specialization. And people that are in particular specialization also don't perform that well on a different discipline. So that's just something that comes with the learning. And why this is novel is that what radiologists currently are doing, they just get the MRI scan, and on scale from 1 to 5, they say, there is some atrophy. I would give it a 3. And yeah, that's quite subjective, right? Because we can give it a confidence interval. We can quantify how much muscle and fat there is. And this is something we can already do, so maybe it's time to put it to practice. Next. After we have saw all the MRI images, it's time to find the proper treatment. And there are different treatments currently available. Some of the most common ones are glucocorticosteroids, and they're kind of the older treatment, and they're commonly used just because they're cheaper. Then right now there are many genetic therapies using exon skipping and also gene transfer. Gene transfer is not currently allowed in European Union, so it's again those bioethical discussions that we need to make, and I highly encourage you during these networking sessions to talk about it. So what we are having is a differential diagnosis, and then using a suite of all these markers that we have gathered from before, including the biopsy, genetic testing, MRI. What LLM can do is to take all these information and find the most likely diagnosis. And that's why it's often better than human, because we just cannot process that much data. So during finding all I have shown you right now, which are our own graphs, and it was developed after having many interviews and discussions with clinicians. We are grateful for all these people that gave us advice, and this is also important when benchmarking these LLMs. It always, as of now, there needs to be a human that comes and double checks, and therefore you don't have to be afraid because there will be still a human double checking it. It just AI is augmenting and speeding up their work. So one thing I haven't addressed yet, and this is me at one of the summer schools. So I was pretending I have severe elbow pain, and then I had the broken wrist. And what LLMs are often failing in is having empathy component. And we're able to sort it to a certain extent in software engineering. So sometimes we introduce new features, and besides giving an injection to patient, we also give it empathy feature. So you feel a little bit better, you get like pat on your shoulder. But it's not truly what empathy is like. Because when we are empathetic, we think about the person. So we just don't do the same thing always. We need to double think and see how the person reacts. And this, ladies and gentlemen, is where reinforcement learning comes into play. And this is Albert. And we'll watch this clip of how Albert learns. So it's a video simulation. And we're asking, can Albert walk? In the end, the story goes on and on. Albert, he's adorable, is given different sort of obstacles. And this is the future of reinforcement learning. So if you want to talk more about it, come to me during networking. And also feel free to ask questions. Now is the time.
Ďakujem veľmi pekne, dámy a páni. To bola Terezia Jurášová. Ak máte na ňu otázky, poprosím vás v rámci obednej prestávky alebo aj kľudne počas celého dňa, nakoľko sme už vo veľkej časovej tiesni. Ďakujem veľmi pekne, potlesk obrovský. Terezia Jurášová. Ďakujem veľmi pekne.